Okay, this problem says, it's a calculator problem, we note. The base of a solid is the region in the first quadrant bounded by the graph y equals 2 minus 2/3 x and the x and y axes as x goes from 0 to 3. From there, we can actually just stop there. Before we read the rest, let's take the top-down view of the region, right, they're describing. They're describing a three-dimensional object, but from the top-down view, we should sketch what that is. So we're sketching it from 0 to 3. So what does y equals 2 minus 2/3 x look like? It has a y-intercept of 2. Okay, again, we're in the first quadrant. And it has a negative slope, so it's going to decrease. Let's ensure we know where the x-axis is, the x-intercept is. It's very likely it's probably 3, but let's just to double check that. So this tells me all right, so the x-intercept is that, and that's all we need. Okay, so there's our line. And so the region they're describing is this one. It's like the top-down view of this object. That's a little bit too much. Okay. For the solid, each cross-section perpendicular to the y-axis is a rectangle whose height is 5 times its width in the xy plane. What is the volume of the solid? Okay, so let's pretend we're looking at the object as if we're like doing the bird's eye view. We're going to slice this object, just slice it somewhere arbitrary there. Okay, we're imagining like kind of slicing it. You kind of imagine slicing it twice to make a piece of bread, where the thickness is, so what is the thickness? Well, so this is the width here is a small change in y, so its thickness is dy. What we're looking at here, the way they described it, right? Each cross-section perpendicular to the y-axis is a rectangle whose height is 5 times its width. So this is its width right here. And if let's kind of zoom in on this. What does this rectangle look like? I'm going to give you the three-dimensional drawing. So let's draw it like coming out. Okay, it's like a diagonal view. It's got a little bit of thickness, our slice here. Okay, this little thickness is a change in y. This is our width, and our height here is apparently 5 times the width. What we need is an expression for the width. Now, this is a horizontal rectangle. Anytime you have a horizontal rectangle in the plane, you need to name all the coordinates in terms of y. So like this coordinate right here, what do I call it? You can call it x comma 2 minus 2/3 x, because the y coordinate as a function of the x coordinate is that. But that's not what we want. We need to switch, this is a dy problem, so we have to name everything in terms of y. Okay, because I basically need the length here. And in order to get that length, I need to subtract x coordinates. This x coordinate's obvious. That's 0, comma y. Let's just note that. But what's this x coordinate? So it's something, comma y, right? It has the same height. What's the x coordinate in terms of y? We're just gonna go over here and okay, we're gonna re-express the x coordinate in terms of the y coordinate. So -2, and then multiply by negative. So we'll just be thorough. Multiply by -3/2. Okay, that's fine. Maybe if you want to distribute, you could get -3/2 x, or -3/2 y, and then this would be plus 3, right? I think I'm gonna. None of this is all optional at this point, but I think I'll write it like that. Okay, so that's how I need to name my x coordinate. It's 3 minus 3/2 y. Okay, and so. Okay, so now what is the length of w? Okay, it's this, right? To get horizontal distances in the plane, you subtract x coordinates, right minus left. So that's 3 minus 2/3 y minus 0. which is just 3 minus 3 halves y. And then my height is 5 times that. So my height is 5 times 3 minus 3 halves y. And so the area here, so the volume here that I'm trying to accumulate, oops, sorry, I won't do that yet. So the volume of this slice here is width times height times thickness. So if I write that first, width times height times thickness, but now we know that the width is 3 minus 3 halves y. My height is 5 times 3 minus 3 halves y. And then my thickness there is dy. So there are the 3 dimensions. Let's kind of collect things a little bit. That could be written as 5 times 3 minus 3 halves y squared dy. Okay, that is the volume of this one slice we took. And what we want to do is our total volume is going to be summing up all such like slices. And you're summing up, this is where you got to be careful, you're summing up as, right? Think about where we could start and stop drawing rectangles. We would start at y equals 0, and we would end at y equals 2. So we're integrating from 0 to 2, this. Okay, and this is where we'll appeal to our calculator. So I'm pretty sure this is 30, but let me just show you on the calculator what I put in. Yep, so that's what I put in, and you get 30. Okay, and so there's our answer.